Thanks for the introduction, Jeric. It's nice to see everyone. Apologies. Good morning, good afternoon, and good evening. No matter anywhere in the world you may be, I'll be presenting about Philippine small satellites. So again, I'm Leur Labrador from the Philippine Space Agency. So before we talk about the synergy, as Professor Ko mentioned in his opening remark, let's go a little bit back in time to where it all started for the Philippines and its foray in the field of space technology, particularly in making small satellites. So back in November of 2013, the strongest typhoon ever recorded happened to pass at the heart of the Philippines, at the very center. It was so big that images taken from space showed that the entire storm covered the all of the Philippine islands. So it was named as Typhoon Haiyan and confirmed to be the strongest typhoon ever recorded in history. As you may have guessed, the aftermath was not very good, particularly in the first parts of the country that were hit, specifically in the eastern coastline of the Philippines. This picture was taken in Leyte, which is a region or a province on the rightmost part closest to the Pacific Ocean in the Philippines. For days, we couldn't really establish contact and we couldn't really tell for sure the situation of the people uh, that were devastated by this very strong typhoon. So the government spent quite a significant amount of money to procure commercial satellite imagery from companies such as Digital Globe. For example, in this image, as you can see, what came after in the left versus what it once was on the right of your screen. So complete devastation. It's as if a tsunami has hit this part of the country. So the government has spent a significant amount to get images and basically information for them or for the Philippine government to respond better in future scenarios such as these. Looking back, the impact of Typhoon Haiyan to the country was very grave. 3.4 million families were affected. That's around 16 million people who lived in more than 1 million households. In terms of damage to the country's finances, being an agricultural country, damage to crops suffered the most, around 9.5 billion pesos damaged in agricultural plants, 6 billion pesos damaged to fisheries, and around 3 billion pesos damage to livestock. So aside from the material damage, it also inflicted a lot of livelihood damage to those who suffered or who were hit by this super typhoon. And it didn't help that we weren't really equipped to respond to these kinds of disasters, these kinds of calamities, because we lacked reliable sources of information. Just to add, the Philippines, in one of the studies done years past, is the fourth most disaster-prone country in the world. And we have around 20 typhoons visit us regularly, yearly. Although thankfully, it's not as strong as Typhoon Haiyan, but you can imagine the type of damage it can do if we have this much typhoon passing over us. And it also doesn't help that we are near the Pacific Ring of Fire, which means that we get a lot of active volcanic activities and sometimes resulting to earthquake and damage to properties. So back then, the mentality right after this typhoon was, yes, there was damage, but how can we prepare better for us to face a future in light of the climate change, the severe weather activities getting more severe? How can we be more ready in the future? And one of the ways suggested is, what if we develop our own capability to gather information through images. And what better vantage point to have than outer space? And so back then, the Philippines, through a project funded by the Department of Science and Technology, embarked on a quest to build Earth observation satellites and start the development of satellites by Filipinos, and with the goal of this being our future source of information in future disasters. So in 2016, basically, I would just like to quickly share, just an aside, I started getting involved in the project back in 2015, and I didn't really imagine that I would be sharing this with you today, that we have maybe around 10 to 12 space assets now in space. We've started, and from that point on, I think the Philippines has never looked back. In 2016, we released the WaterOne, a nano satellite. In 2018, the WaterTwo, another microsatellite, was released in 2018, followed by a suite of nanosatellites in Maya2 to Maya6. And it's also very encouraging to see ASEAN-SAT-1 join the mix, another nanosatellite, which the next presenter would discuss further. And finally, our most ambitious project so far in Mula. So I'll be going over these satellites in the next slides. So the WaterOne started it all for Earth observation small satellites in the Philippines. It was a 52-kilogram low Earth orbit satellite. It was deployed from the International Space Station. As you can see on the very nice video on your screens, this was taken by astronauts that were stationed during that time in the ISS. So the WaterOne was made in partnership with Japanese universities, particularly Tohoku University and Hokkaido University. So they developed the bus as well as the payloads, respectively. So it was released in 2016, April 27th, from the ISS. And as you may have guessed, it contained a lot of imaging payloads. It had a high precision telescope, which is able to capture 5-meter GSD images, although at relatively smaller swaths of around 3 by 3 kilometers. But one of the more exciting payloads that was born by the WaterOne is SMI, which is the spaceborne multispectral imager. So it's a multispectral imager, as the name may reveal, but this has a liquid crystal tunable filter. Basically, what it does is it can change frequencies or wavelengths, optical wavelengths, while it is in orbit. So depending on the type of observation that we would like to conduct, then we can instruct the SMI to capture at the wavelength that would best suit the observation type. It also has supplemental payloads, such as the middle field camera and the wide field camera. So it was a very exciting development for us. It was a pretty lean team. I think it was around 9 engineers directly working on it. But of course, much more support of engineers, especially in the Philippines, preparing the ground station as well as the local activities to ensure the continuity of this project. It was decommissioned in 2020 after covering around 40 to 50% of the country. And one of the things that we've learned is the low Earth orbit ISS, while it may introduce a lot of revisit times in some months, it's not this. You can't really say the same for the entire year, and so that's something that we looked forward to changing in the next iteration, which is the WaterTwo. The WaterTwo was launched in October 29, 2018, but instead of docking in the ISS temporarily, it was injected straight into orbit, which is a sun-synchronous orbit, 600 kilometers. So having an SSO orbit gives us the opportunity to capture the same location, roughly the same location at roughly the same time of day. So that gives us a temporal uh, temporal manner to observe what has changed in a certain area, see how it is progressing, and use it not only for disaster but also for forecasting, which by this time we have seen, or we have been slowly seeing, the advantages of having our own satellites, Earth observation satellites, in doing so. So aside from the 4 payloads that were mounted in the WaterOne, we added 2 particularly important upgrades. The first is the enhanced resolution camera, which worked very well with the SMI, the multispectral imager, because it can pan sharpen images, but this time at a much larger swath widths. At the same time, we became a bit ambitious and tried to address the problem of communications as well. And so we mounted the amateur radio unit. We were very proud of it because it was made almost entirely in the Philippines and then brought to Japan and then flown into space. And it's operational and still is. And it's used in times of disaster. In case the conventional networks are down, we can use the amateur radio unit mounted in the WaterTwo to as another means of communications. Right. Now, let's look at MayaOne. While everything is going on in terms of the WaterOne and the WaterTwo, we're also building our capability in terms of having the know-how to build nanosatellites, but more importantly, knowing about the systems, knowing about how everything interacts, and in the future, bringing that expertise into the Philippines and applying it to larger projects, larger systems, and hopefully scaling it up to more ambitious missions. So MayaOne signified the start of that goal. It's a CubeSat and released from the ISS. It was part of the BIRDS-2 project, released August 2018 in the International Space Station. It also has a camera, but at the same time, being a technology demonstration satellite, there were payloads that are mainly for checking if they can really work well in space, such as a GPS chip that was pretty new at that time, and a single event latch-up monitor, which will basically tell you if the satellite will sustain a damage from the ill effects of radiation. So these CubeSats, while very small, are very capable, and especially for technology demonstration. So it was eventually decommissioned in 2020, November, but it didn't stop there, as Maya2 was developed next. And this time, it was parts of the BIRDS-4 project. It's still a nanosatellite, but it sought to improve the features that were introduced by MayaOne. It also has a camera. This time, it has a perovskite solar cell, which is a fairly experimental solar cell, but high efficiency at that. And it also has a latch-up detection chip and ATCS control units. It was, again, after almost a year in space, decommissioned by July of 2022. Right after that, this was another milestone in the Philippines as we tried to replicate the BIRDS project in Japan and started our own microsatellite track in the country. And Maya3 and Maya4 were the 2 cube satellites that were the direct result of that activity. This was developed almost entirely in the Philippines. Some tests, electrical tests, were done in the Philippines, but the final tests were done in Japan before being flown into space in October of 2021, when it was finally deployed from the ISS. And it introduced some technology demonstration payloads as well, such as another GPS chip, and this time a near-infrared camera. that was placed in Maya4. Fairly recently, this month, both Maya3 and Maya4 returned to orbit and burned up in the atmosphere, but only after providing valuable information in terms of technology demonstration and satisfying their mission requirements, which is also to capture images of the Earth. Maya5 and 6 will seek to build on top of the developments of the first batch of Filipino scholars who developed Maya3 and 4. They are currently in the process of testing their flight model, and hopefully by 2023, they would be able to launch the satellite. And I think this is again via deployment from the International Space Station. So this time, they'll use or at least retain some of the mission payloads flown in Maya 4, Maya 3 and 4, but in Maya 6, they will be adding an onboard computer, an experimental onboard computer, which seeks to start the Filipino line of onboard computing units that we can use the parts which can be sourced locally or at least manufactured, fabricated in the Philippines for us to be better able to manufacture nanosatellites in the future in country at a much faster pace. And as I've mentioned, ASEAN-SAT-1 is another nanosatellite that's being developed in country, this time via the University of Perpetual Help System, DALTA, which will be the next presenter. And they're developing this one in collaboration with other universities across the ASEAN region. So those are the nanosatellites and microsatellites. And finally, this is the latest project that we are doing, which is the Multispectral Unit for Land Assessment, or Mula. We have moved to a direction wherein we would like to have a satellite that we could call as an operational, meaning that it will yield enough information for us to gather, extract actionable insights from the data that we will have, but at the same time provide the opportunity for us to sell those data not only in country but also outside of the country. And so it's a small satellite, a bit larger, 130 kilograms. It will be released again in sun-synchronous orbit to have more regular revisit intervals, and it will have firstly an optical payload, just called a true color multispectral imager, which can capture 5-meter GST, but a much larger swath compared to the WaterOne and the WaterTwo. It will also have AIS and ADS-B payloads for detection of ships as well as aircraft when it passes by Philippine territory. The launch is still to be determined, as this project is still being developed in partnership with a UK company called SSTL, Surrey Satellite Technology Limited, which has a KHTT know-how transfer training program, and the Philippines will be sending engineers to work hand on hand with their engineers and taking back the license to rebuild this class of satellite and making or jump-starting the space industry in the Philippines once they do return. So that's the larger picture. Before I end, I would like to show this video prepared for Mula.
When the Philippines began building satellites, we started small. As small as a suitcase. Yet the stakes were high and the challenges were great. After the success with 6 of these small satellites, the Philippines is ready for something bigger. In December 2020, the Philippines kicked off the Multispectral Unit for Land Assessment, or Mula satellite project. Weighing around 130 kilograms, Mula will carry a true color camera that can capture higher resolution images, covering around 73,000 square kilometers of our country in one day. Data from Mula satellite will be used for addressing food security, disaster resilience, environment conservation, and protecting our national sovereignty. The Department of Science and Technology jump-started the funding of Mula. The project was jointly implemented by the DOST, Advanced Science and Technology Institute, and the University of the Philippines, Diliman, in coordination with the Philippine Space Agency, or PhilSA. 16 Filipino engineers who underwent a know-how training and transfer program in the UK are involved in building the satellite and are now part of PhilSA. The training capacitated our homegrown engineers, not just with knowledge, but the license to build more local commercial satellites in the future, leading the way for the creation of a robust and thriving space industry to support the country's space program. PhilSA will oversee the completion and launch of Mula and manage its operations. Mula in Ilocano means plant, pointing to the satellite's mission on food security. In Tagalog, it means point of origin or beginning, which symbolically signals the Philippines' foray into a new era in satellite development toward the vision of a nation bridged, uplifted, and empowered through the peaceful uses of outer space. When the
That's the end of my presentation. Thank you very much for your attention and looking forward to any questions or comments you may have. Thank you.